Alright, let's look at the homework 3, problem number 5. Alright, it says that the half-life of radioactive cobalt is 5.27 years. Alright, so since radioactive cobalt decays exponentially, so we can write it as, let's see, I'm going to call it the C of T. Alright, so I'm going to use blue. C of T is going to be whatever the initial value, which is C0, right? Then we have e to the negative kt, right? So I put the negative sign because it's a decaying. All right. Then so it takes 5.27 years. So which means that we have this clue after 5.27 years. Right, which is C0 e to the negative k times 5.27 is going to be half of the original amount. So 1/2 of C0. C0 is the original amount. Right. So this will give us the clue to find the k. Or I think what I'm going to do is I'm lazy, so I'm going to try to find e to the negative k. Alright? Alright, first thing is I'm going to divide through by C0. So that way we can get rid of C0. So you have e to the negative k, and 5.27 is equal to 1/2. Right? Then what we're going to do is I'm going to solve for e to the negative k. So this is going to be, I'm going to raise it to the 1 over 5.27. So which will give us e to the negative k is going to be 1/2 raise it to the 1 over 5.27. Alright, so therefore we have this equation. So this tells us that the equation is going to be, so here I'm going to go up here, right? So it's a C0, right? E to the kt is 1/2 raise it to the 1 over 5.27, but we want to raise it to the t, so this is the equation, right? So once you got that, then it says that, let's see, a nuclear accident that has left the level of cobalt radiation in a certain region at 100 times the level acceptable human habitation. Right? So we want to know how long it takes the original amount to become 1/100th of the amount, because initially we have 100 times the acceptable amount. Right? So what you need to do is we need to set up the equation. So we want to find t. So c of t, which is C0, 1/2 raise it to the t over 5.27, and we want this guy to be 1 over 100 of the original amount, C0. Right? Then use this equation and solve for t value. Right? So that's going to be the value here, which is about 35 years, but I'll let you fill this in. All right, that's it. I hope that this will get you guys going.